Good evening. So, in the previous lecture, we discussed about the divide and conquer approach and how the divide and conquer approach is splitted in three parts: divide, conquer, and combine. And throughout the particular divide and conquer approach, what are the examples are there? We saw with the quick sort, mod sort, closest pair of points, maximum Sobarism, and Strassens and Karatsuba algorithm. And I discussed some of the problems regarding the maximum Sobarism. Okay. So in this class, we are going to be discussed about another approach, that is Karatsuba faster integer multiplication algorithm. So this algorithm also coming under your divide and conquer approach. Okay. So first of all, we'll start with the Karatsuba faster integer multiplication algorithm, how it is works. So first of all, basic high school multiplication name approach is of order big of n square. So this is the basic things whenever we are doing the integer multiplication. So that kind of multiplication algorithm. So this algorithm follows the naive approach, that is big of n square. That means time complexity is very high in this particular algorithm. And number of digits is n here. So for large numbers n, not efficient. If you're considering with the large number of n, then this algorithm is not efficient algorithm. And in encrypted communication, computer needs to perform multiplication with larger numbers. Whenever we are going with the encrypted communication, okay, the computer basically required the perform multiplication with large numbers. That time you can't do with very small numbers and multiply it. So whenever we are doing with a large number multiplication, that time we need to work with the Karatsuba faster integer multiplication. Okay. So basically there what we have to do, we have to work with a large number, that is hundreds or even thousands or more than thousands also. We have to work on the particular algorithm. So how the Karatsuba algorithm helps here? So here the perform the operation more efficiently. So whenever we work with the normal integer multiplication with very like less number or a small number, then it is easy. But whenever we move with the like a larger number, more than hundreds or thousands, that time this Karatsuba algorithm helps us to perform the operation more efficiently. Okay. Then efficient divide and conquer method. So basically this algorithm is otherwise known as one efficient algorithm over the divide and conquer method. Whenever we are dividing the input into solve problems, then when we are doing the integer multiplication, this algorithm acts as a efficient approach. So this is one of the efficient algorithm of the divide and conquer method. So this is the basic concept of Karatsuba faster integer multiplication. Here, what is the important concern? Important concern is this algorithm follows the naive method. So if it will be follows the naive method, it will be goes with the time complexity of big of n square. Okay. Then it will be works over what? It will be works for a efficient operation. That means it can work for the larger numbers and it will be provides the efficient results. Okay. So this is about the Karatsuba faster integer multiplication algorithm. So here you can see easily the integers are given. So in this integer, you can see the multiplication. Then how we do the normal multiplication in a high school level. So just integer multiplication. Okay. So this is the answer. If normally we are doing, it is taking more time. But if we are using this Karatsuba faster integer multiplication algorithm, how it is happening, that we have to check throughout this particular algorithm. Okay. So here you saw normally 4 5 2 6 3 4 7. If you will be do 6 7 7 6 ja 42, 2 4 7 2 ja 14, then 14 4 18 8 1, like this you have to continue multiply. Then once you multiply all the digits and sum up, then you will get this answer. Okay. I hope you know these basic things. I'm not discussing about it. So next we'll move with the Karatsuba faster integer multiplication algorithm, basically how it is work. So first of all, here the input is given 1 4 6 1 2 3, and in y axis 3 5 2 1 2 0. Okay, so here the R is given. That is, here you can see. So here you have to divide into by the help of divide and conquer. So here n by 2 means 146, 123. Here also 352, 120. So now what we have to 146, 123. So 146 triple zero, okay, plus 123. Then that means 146 into 10 to the power 3 because three numbers here. So plus 123. So next 352, 120, 352, 30 will be added for this plus 120. So 352 multiplication of 10 to the power 3 because for 3 digits. So here 10 to the power 3 plus 120. So if we are adding this, then we will be get the, so this is about our Karatsuba faster integer multiplication. So the formula you can see here, x equal to a into 10 to the power n by 2 plus b, y equal to c into 10 to the power n by 2 plus d. This is for this one. Then x into y is equal to a into 10 to the power n by 2 plus b. Then c into 10 to the power n by 2 plus d. Then we have to just do the multiplication again. A c into 10 to the power n by 2. N by 2 is 2 to the 2m. ad plus bc into 10 to the power m plus bd. Okay. Then ac into 10 to the power 2m plus a plus b, c plus d, ac minus ad into 10 to the power m plus bd. So here you have to follow this formula, a plus b, c plus d minus ac bd, then ac plus ad plus bc minus bd minus ac minus bd. If you will be put plus minus cancel means we will be get finally ad plus bc. Okay. Then here the n is equals to maximum size base of 10 number 1. Size underscore base 10 number 2. Then here what is the floor here? M is equals to floor of n by 2. Okay. So next what we have to do? Next, once you done with this Karatsuba faster integer multiplication algorithm throughout the example, then you can try with certain algorithm, like how the algorithm works here. Okay. So this is very simple. If will be take the input in a two values means x and y will be given, you have to just beat by the help of n by 2 formula. Okay, you have to take equally. Okay, once you taken, you just need to be convert like this, then you have to put the formula and you have to split up and get the answer. That's all. This is about the Karatsuba faster integer multiplication algorithm. This is one of the algorithm. So this is the algorithm. How basically it is work. First of all, you have to take the x and y, that means inputs. If x is x less than 10, if x is less than 10 or y is less than 10, then return x into y. Okay. If this condition, then we have to return with x into y. N is maximum size underscore base 10 number 1, size base 10 number 2. So whatever the number will be there, base 10 of for the number 1, base 10 for the number 2. Then m equal to floor of n by 2. Cell floor, you know these things. I think I don't want to explain this. What is floor, what is cell? So you have to take the m equal to floor of n by 2, ab split underscore at x comma m. Then cd split underscore at y comma m. So ac corresponds to a comma c, bd corresponds to b comma d. Then ad plus bc, then corresponds to a plus b, c plus d minus ac minus bd. So finally it will be written this ac into 10 to the power 2m plus ad plus bc into 10 to the power m plus bd. Okay, so this is the Karatsuba algorithm. Okay, so once you will be move with very like in efficient way, if you will be understand how this xy is computed over this and how this cell and floor is work, okay, how to split, okay, then how this Karatsuba algorithm worked. So first of all, you have to get the depth analysis of the particular algorithm, how the integer multiplication is happening. Okay, once you understand the core concept of that, then easily you can able to be identify and easily you can able to be compute here how to work efficiently throughout this particular algorithm. Okay, so here you can see the same thing. Here what happened, here how this algorithm is proved throughout a tree. So Karatsuba example, you can see first of all the given number is given a b c d. Okay, so you have to split. So k of 146 352, here 352 120. Okay. So first of all again 1435, k of 6 2. 20, 37, then based on this formula, okay. Then K of 12, 12, K of 30, 0, K of 15, 12. Then here 269, 472, then 26, 47, 92, 35, 49. Then again 1, 3, 4, 5, 6, K of 5, 8. Then 20 is K, 1, 1, 2, 2, 3, 3. Okay, for this. Then here again 2, 4, 6, 7, 8, 11. Okay, next you have to, like this, you have to split it. So finally, you have to get the output like this. This is the example. Okay, try to solve it. If any doubt, you just ask me, then only I will be conceptually move with the one by one problem. Because initially, if I will be tell you how it is working and how we are going to be solved, it will be difficult for you to understand. So first of all, you keep some mind, and once again we will be go with the this explanation how this thing is basically working. I'll become with the particular example throughout the videos. Then you can easily grasp it where exactly we have to analyze, and once we analyzed, then how we are going to be compute over the particular formula and get the solution. Okay, so first of all, in this lecture, you just analyze the basic concepts. Okay, how it is working. Then another video we have to come with the entire problem and we need to solve it. Okay, so this is about your so now again you have to be split over this example, and next finally you have to get this up to 1245 104. So finally you have to get the solution like this. So final multiplication result is coming like this. Okay, so now you can see this is about your Karatsuba algorithm time complexity. Okay, so in all the algorithm we are doing the time complexity analysis. So from this, whenever we are going with the Karatsuba algorithm, here the time complexity is n equal to number of digits. Okay, how many number of digits is mentioned? So based on that, T of n is equal to 3T of n by 2 plus theta of n. Okay, this is your time complexity. That means, suppose you see here, function, suppose we taken two variable x and y and we assign the values. If x is less than 10 or y is less than 10, return x into y. This is the formula. So n is equals to max size of underscore base 10 number 1, size base 10 number 2. Okay, this is already I spoken, but again you can analyze. M is equal to floor of n by 2. Again we have to take AB split at xm. Again we have to split it. CD split at ym. Okay, again we have to split over y. AC Karatsuba AC. Then the formula will be moved with T of n by 2. Then BD Karatsuba B of D. T n by 2. Then add plus BC Karatsuba A plus B. C plus T minus AC minus BD. So again it will be moved with the T n by 2. So now you see so this is based on what? The time complexity is here based on the n number of digits. So that here, as it is working over the 3, so T of n is equal to 3T n by 2 plus theta of n. Then it will be written with AC into 10 of 2m plus AD plus VC into 10 to the power m plus B D. Okay. So the complexity over here, theta of n. Okay. So now we'll move with the next part. So this is about your Karatsuba algorithm time complexity analysis. So first of all, we understood how we have to go with T of n, A of t, n by b plus E of n to the power c log dn. Okay, so throughout this, we have to apply the formula. T of n is equals to 3t n by 2 plus theta of n. So based on the value, A equal to 3, B equal to 2, C is equals to 1, D equal to 0. So here we have to just compute log B of A, log for 3 equal to 1.5n. This formula you can take it from the like scientific calculator. If you'll use, you will be get E of n. So case 1, C is less than log BA. So it will be moved with C less than log BA implies to T to the power n theta of n log BA is equal to theta of n 1.58. This is the time complexity analysis for this. So the master theorem is this. If you will be go with from this, how this theta of n n 1.58 is derived. So T of n is equal to ATN by B plus theta NC log DN. C less than log BA plus implies to T to the power n is equals to theta of n log BA, then C equal to log BA, D greater than minus 1 T of n, then NC log D plus 1 n. Then D is equals to minus 1 T to the power n, then NC log log n. Okay, D less than minus 1 T to the power n theta NC log BA, D greater than equal to 0 T of n theta NC log Dn, D less than 0 T of n theta NC. Okay, so this is about the Karatsuba algorithm, time complexity analysis, and how it is working whenever we are working with a divide and conquer approach. So this is one of the example of divide and conquer approach, and this is a very efficient algorithm. But the problem is here the time complexity is going with more. Okay, so speed of algorithm is reducing, so that we move with the another algorithm in the next class. Okay, so in this approach, basically what we understood. So first of all, how this Karatsuba faster integer multiplication is working, and how it can be have the impact whenever we are just multiplying with the large integer values. Okay, and what is the time complexity and which method basically it is following? It is following the name method, and the time complexity is works over the number of digits. Okay, and basically here we are considering this time complexity. We go of n square whenever it is, this is the order. Okay, the order is moving with big of n square, but the time complexity analysis if we are doing, this time complexity analysis is depends on the number of digits. Okay, that is what here it is mentioned. T of n is equal to 3t n by 2 plus theta of n. Okay, thank you. Just go through it. If any doubt, you can ask me over the comment section, and I will try to clarify your doubts. In the coming classes, we will be see with the other examples and how this problem we can able to be solved. Okay, so try to get the basic concept and ideology of the particular algorithm. Then it will be very easy to grasp up of the problems whenever you are solving throughout these examples. So try it out. Any help, any doubt, you can put in the comment section. I'll be happy to give you the answers. Okay, thank you so much. So with this, we will be wind up this session. We will meet in the next lecture. Thank you.